Degrees to radians, radians to degrees. It's pretty simple shit, especially if you got a calculator. But I'm kind of a jerk and I like exact answers. So if you give me some decimal approximation to a lot of things, that's going to be incorrect. So exact means it's the exact answer. It means this doesn't your calculator screen isn't filled up with a bunch of decimals. Put it that way. Put it that way. That's an exact answer. We'll talk about some of these. So we want to be able to go from degrees to radians, degrees to radians, and vice versa, radians to degrees. Well, we need something that ties them together. And we learned that 2 pi, going around in a circle, 2 pi radians. And again, we don't typically write radians. I'm doing it here just to show you. It's equal to 360 degrees. It's implied that if you just write 2 pi is equal to 360, you're speaking of radians. But we'll write it then, or rad. But this isn't the conversion we really use. We do a quick, let's divide both sides by 2, and we say that pi radians is the exact same thing as 180 degrees when we're looking at this as a unit of measure. And you're like, oh, sweet, that's super cool. But what this allows us to do, that if you want to you want to get your, you want to take your degrees, you got something in degrees, you want to take it into radians? Let's go. Let's watch how this works. Because we're going to end up with 2 different conversion factors. Pi over 180 degrees, or 180 degrees over pi. These 2 things, these are your dudes. These are your dudes. We're going to multiply. If you're in degrees, you'll multiply by what's in purple. If you are in radians and you want to go to degrees, you're going to multiply by this. And it's pretty simple. You can kind of get them confused a little bit here and there, but I think there's some quick ways to see how to do these conversions. So let's start off with a nice simple one, the one we already know the answer to. Okay? So let's go with 90 degrees, and I want to convert this into radians. So what we're going to do is we look, and the way I remember it is, if you've ever done a chemistry class or a physics class, your units have to cancel. So if we're going to multiply by something, I think multiplying by this one here, this conversion, this pi over 180 degrees, that has to be the right one, because look at the units. That's degrees. They'll cancel out, going into radians. So we put this in, and you got 90 pi over 180. But 90 goes into 180 evenly. 90 over 180, look at that, the zeros go away, so you have 9 pi over 18, you don't have to show all these steps, and then isn't 18 just 9 times 2, and then that cancels out too, and then you have pi over 2. Right, didn't we already know that? The 90 degrees was the same thing as pi over 2, our quadrantial angles. Let's go again. Let's take another one. Let's take 60 degrees. Let's go find out what 60 degrees might be in radians. We want to go find out. What's that thing in radians? I'm sorry, I didn't pinch my answer on that one. So let's do this one. We'll call that one problem 1. This one's problem 2. So we'll take our 60 degrees, and once again, we're going to use that same conversion. That same piece from right up above. That will pi times 180. We put it in, or pi over 180. My bad, I misspoke. Now again, we can tell because the degrees will just cancel out. And this is going to leave us with 60 pi over 180. Now if you look, the zeros cancel out, and 6 goes into 18 a few times. I think 6 goes into 18 how many times? Isn't that 6 times 3? Isn't that 18? So the 6's go away, and we find out that this is equal to pi over 3. 60 degrees and pi over 3 are the same thing. Now, you won't have to do this on these common angles, because we deal with 30s, 60s, 90s a lot. 45s, 90s, 135s. We deal with those a lot, and you should get those memorized after a little while. Let's go to another. I want to knock out a few of these and then say this is a big one. So 30 degrees. we want to see what this is in radians. Now I just want to use logic. There's a conversion and you can do it, and I'll run it real quick. 30 degrees times those, let's just bring it down. Pi over 180, right? We do this, and that's 30 pi over 180, and it ends up being pi over 6 after you do your reduction. All right, that's cool. But isn't 30 half as big as 60? Isn't 30, isn't this one half the size of this one? Isn't 30 half the size of 60? So what's half of 60 degrees? Half of, right? When half of something is you multiply it by a half, right? Divided by 2, same thing as multiplying by a half. This is equal to what? 1 times pi is pi, 3 times 2 is 6. Pi over 6. So 60 degrees is just twice as big as 30 degrees. Pi over 3 is twice as big as pi over 6. Bigger denominator, smaller number. Bigger denominator, smaller number. All right. Neat. Let's go the other direction. Let's take something in radians. Let's take my buddy 3 pi over 4. Let's mess around with that. 3 pi over 4. And we want to convert this into degrees. Well, now we're not gonna use our same formula. We want to look back up top and go, oh dude, we need that shit in green. We need that shit in green. 3 pi over 4, we better get a lot of times we think about it this way, the pi's are going to cancel out. Whatever was in there. So we're going to use this bad boy here. I won't. So 180 degrees over pi. Typically we measure radians in multiples of pi. So that's how we know. So look, pi's go away. Hiya. Dope. So let's go over, and now we have 3 times 180 degrees over 4. Now, if you're doing this by hand, do you want to multiply 180 by 4 or by 3 and then make it larger and then do long division? Or do you want to do 180 divided by 4 first? And let me just show you, 180 is this. So can you cut that in fourths? Cut that in fourths? Cut it in half, that's 90. What's half of 90? 45. 45 plus 45 plus 45 is equal to 180. So I'm just playing some number games with you, if you don't mind. And then the 4's go away, and then 3 times 45, shit, it's 135 degrees. But I imagine a lot of you guys didn't do this with your calculator. That's chill. Do you? Just as long as you go back and forth between the things. I need to make sure that you know how to do this. Quite important. And I'm just going to do one more and show you how to find an exact answer. I want to find this one exactly, so you're not going to like me much right now. Let's say that this is going to be, I don't know, let's be a total, you mind if I be a total jerk about this? Let's claim that this is going to be 252 degrees, and I want this to be an exactly correct in radians. Exact. This is big. I use this shit a lot. Exactly correct. That means no decimals out of a calculator. So you're not just going, oh, 252 times pi over 180, and I get this decimal. No, I'm a math teacher. I'm not a physics teacher. So it's 252 degrees times, and is it going to be the 180 up top? Would it make sense if you put the degrees right next to each other? Of course not. Of course not. You're going to want your degrees down below. You're going to want your pi up top. Shit. Degrees went away. So now we have 252 pi over 180. And this gets to your teacher's biggest pet peeve. And that's even numbers over even numbers. It drives me nuts when students leave this. Do not leave an even number. Does everybody know what half of something is? Does everybody know what an even number is? Well, if you have an even over even, 252. What's half of 252? That might be the hardest frickin' part, is figuring out what the heck, what is that? 126 pi. And then what's half of 180? It's 90. Shit. We got another even number over even number. Notice I ignored the pi. The pi goes along with the right. It's just a multiplication. We still got an even over an even. So what's half of 126? What's that? 63 pi over 7. That's 45. All right. This is still not reduced all the way. Sorry, that's my dog. You're going to hear him wandering around. He's got the longest nails ever, and you can't cut him. It's wonderful. This is still can be reduced, but your teacher would not be pissed off at you for leaving an even over an even. We can continue going on. All of this is divisible by 3. 63 is actually 21 times 3 times pi, and 45. That's 15 times 3, so the 3's go there, and oh shit, it keeps going. Oh my gosh, 21 pi over 15. It's still both divisible by 3. This ends up becoming 7 pi over 5. Holy crap. Could you do that? Are you able to take these things down? Or maybe you got a calculator that's powerful enough to do it for you. But I need you to be able to find exact answers like this, being able to play around with this little conversion factor. It's going to be in your homework. You get a couple examples like this. But soon, it's not just going to be one little problem in your homework. This will just be part 6 of 12 things that you're going to end up doing. So we want to be proficient with it. Okay. I didn't get to complementary or supplementary angles. We'll do that one in the next. I'll see you there.